Okay, so just wanted to use our simulation to demonstrate a couple of effects. So first thing is I'm just going to use the balloon, rub it across the jumper, and we managed to pick up all of the charges, all of those spare charges. Please bear in mind that it's the negative charges that are being collected. Negative charges because those are the ones that are electrons. And even if I pull it out here, it still seems to just get attracted towards those positive charges. So that should, and I think most people have figured this one out. We've got unlike signs that repel, so we've got unlike charges repelling one another. I can add in a wall here on the right hand side, and I can see what happens when I force the balloon to go on over here. So up until this point, up until around here, it wants to go to the left because I've got more charge on the left. Then as I bring the balloon closer to the wall, if you notice, those negative electrons are actually pushed out of the way by the force of repulsion from these ones, and that allows the electrons to have an attractive force between those ones and the positive charges that are on this side. So this does something to objects. It polarizes them. Okay, that's called polarization. When you induce, the word would be to induce a change or you induce, you cause something to happen by induction. Okay, you're kind of using those electrons to force those other electrons out of the way, and that allows us to have positive negative attraction here between the blue and the red charges. So now we'll introduce a second balloon here and just see what happens. I release it from here, and this balloon heads straight towards the jumper because it is drawn more to the jumper than it is to this green balloon. This green balloon is what we would say electrically neutral because it's got as many positive charges as it has negative charges, whereas the yellow one has got a dominant negative charge overall. Okay. So, like we said in the previous simulation, we were charging by friction. Okay. So here we've got another simulation. It's all from Travoltage. John says lines like this. You can see that he's picking up those extra electrons or those extra charges from the mat that he's standing on. And of course, if he was to bring his finger a little bit closer to the doorknob, then eventually those charges discharge. The word is discharge. They discharge across the air between his finger and the doorknob. And I'm sure many of you will have experienced this in life yourself. You'll notice that. Sure. I know it happens to me a lot when I'm in a shopping mall, especially if I'm wearing any particular kinds of shoes. Some are more prone to building up a charge than others and then discharging when we meet some grounded object. Okay, so we're building up some charge, so we're taking electrons or we're losing electrons. Okay, and we'll come to that in just one moment. I just wanted to show those two effects in one video.